you have a good summer?
Yeah, Laurel, how about you?
I had a terrific time at music camp. What's your next class?
Lab.
Me too.
Well, Greta, you're looking good.
Thanks, Nick.
Hi, Greta. What's your next class?
Science lab.
Me too.
That makes it better.
Hello, Laurel.
Hi, Roy.
Hi. As you come into the class, check the list on the board. You'll see that each of you has been given a seating assignment. At your place, you'll find protective eyewear and a lab apron. Put them on to get used to wearing them. This morning, we're going to cultivate your lab safety awareness. Excuse me, would you please tie back your hair? May I ask what your name is?
It's Greta.
I'm Mrs. Williamson.
Mrs. Williamson, the principal said it's okay for me to leave my hair down.
It's okay everywhere else in school, Greta, but the lab is a special place and requires special safety measures and awareness for all of us. Please put on your eye protection and the apron. You'll be expected to wear your lab gear for every lab period. And young man with the sunglasses around his neck? Yes, that's right. What's your name, please?
It's Nick.
Nice to meet you, Nick. Please take the glasses from around your neck. You see, they're likely to get in the way and could be dangerous in the lab. Thanks.
Look at these goggles. They look goofy.
I'm not going to wear these. I got contacts so I wouldn't have to wear glasses.
Look at this apron. It's awful. Everyone's always telling me what to do. I don't see why I have to wear this. I'll just wear some old clothes.
More stupid rules.
In this class, we don't do anything without a reason. That's because this is science. I'm glad you're questioning the rules, because in science, we don't take anything for granted. The lab is the place where we find things out, so we always have to be prepared for surprises. In fact, that's how scientists make discoveries. So ask questions and try to find answers. That's rule 1 in this class. Expect to be surprised. And because we can expect the unexpected, there are rules and procedures, so you'll need to follow directions. Most are to protect you, like these high-fashion lab aprons and eye protection. In this class, we're going to focus on lab safety awareness to help you avoid common accidents. Being safe in the lab means developing good habits, using your common sense, and staying alert. Remember, in the lab, surprises can and do happen. So no matter how lab safety aware you become, there's no prospect of anticipating every accident. So practice safe science. Wear your safety gear, follow lab procedures and directions, and listen to your teacher. Surprises will happen anyway, so don't assume anything. In the lab, when we try to control an experiment, we very often use heat. So let's talk about using heat safely in the lab. Here we have several methods of heating things in a laboratory: a candle, a Bunsen burner, and a hot plate. First, let's light the candle. Use safety matches because they're longer and stiffer than book matches. Remember to use one at a time. Strike the match away from your body and light the candle fairly fast so you won't burn your fingers. Remember, never assume anything. If you're using the Bunsen burner, as soon as the gas is on, just a little, light the burner, always with a safety match or striker, and you'll want the burner within arm's length, but not close enough to burn your clothes. If you were using this electric hot plate, it would need to be plugged into a grounded outlet. Sometimes you will find plugs designed to be used with a polarized outlet. They have 2 prongs of unequal size. Make sure anything is plugged in all the way so it's safe to use. Also remember that people conduct electricity. So you could get a shock or do serious damage to yourself if there's anything wrong with the equipment or if you're using it improperly. Just because you can't see electricity doesn't mean you're not at risk. Let's take this little toy and do a demonstration. Nick and Greta, could you come up here, please? Nick, if you would place this hand on the chick and hold its little battery terminal on the belly. There. Right. And I'm going to hold this one. And I'm going to hold Greta's hand. And when I say go, why don't you hold Greta's other hand, complete the circle, and we'll complete the circuit. Okay? Ready? Go. Thanks. Didn't know how electric you were, did you? Ladies and gentlemen, electricity travels through people. Don't underestimate its ability to harm you. Also, make sure that liquids are kept away from outlets and from appliances not designed to be used with liquids. You don't want liquids to spill when electrical equipment is used. If you see a frayed wire, or if you think that something isn't operating properly, you're at risk. Don't assume anything. Notify your teacher.
Miss Wilson, there's a fire in the wastebasket.
Thank you, Roy. Everybody all right? Thank you, Roy. You did just the right thing. If you see a fire starting in the lab, call me. There's a fire extinguisher in every lab. Make sure you know where it is before you start to work. If you see a fire, do what I did. Walk, don't run. Get the fire extinguisher, hold the pin, aim directly at the fire, push the lever, and fire. Now, remember when I said never assume anything? Never assume that because you shake a match like this or blow it out lightly, that it still can't start a fire. What should I have done, Nick?
Let the match cool before you toss it.
That's good. But how do I know when it's cool enough? Greta?
When it dresses like Nick.
Roy?
You should wet the match. Then you'll know it's cool enough.
Exactly right. Thank you for being so lab safety aware. Now, even though we try to be prepared for surprises by wearing safety gear and staying alert like Roy, we try to minimize surprises by thinking ahead. That's also why, for example, when we use a candle, we often stick it in a pie tin and put water around the candle. That way there's a place for used matches. No surprises. Also, the water will put out the flame from the candle if the candle tips over. Now, if I can have another volunteer, we'll learn a different way to put out a fire. Roy, come on, you've earned this.
What do I do?
Let's pretend there was still a fire in the wastebasket. Get the fire blanket and use it to smother the fire.
Where is it?
You shouldn't start to work until you know where the fire extinguisher, the fire blanket, and the fire exits are. It's over there. Now walk, don't run, get the fire blanket, open it up, and use it to smother the pretend fire. Ready? Go. Excellent. One more thing. What if you'd hurt yourself while you were putting out the fire? What would you have done?
Well, I would have probably talked to the teacher or even gone to the school nurse.
Both sensible answers. What about a first aid kit?
Well, I didn't even know where the fire blanket was either.
If we look around for a red or green cross, you've most likely found your first aid kit. Voila. All right. Now let's talk about what happened as we were coming into the lab. Why do you think I asked Greta to tie back her hair?
It might get too close to the flame she's using and catch on fire.
That's why I singled you out, Greta. Also, hair can catch on fire if someone else uses a flame. Sometimes it's easy for us to think about our own actions, but we aren't always aware of what someone near us will do. What's another thing we should think about to prevent fires?
What about a scarf or something that might catch on fire?
Excellent answer. Scarves, sashes, long droopy sleeves, neckties, dangling jewelry, all can easily catch on fire. They can also hook on to equipment and knock things over, causing various accidents. If you wear loose clothing, tie it back or contain it, maybe with your lab apron. You can roll up loose sleeves. Remember when Nick came into the class with his sunglasses draped around his neck on a nylon cord and I asked him to take them off? Now you know why, Nick. I didn't want you to strangle yourself, or at least get you tangled up and perhaps set yourself on fire. And Nick, just to let you know that I hold myself to the same standards, I had to change from these to these to protect my feet from spatters, breaking glass, burns, you name it. From now on, you're on notice that I won't let you through the lab door without closed-toed shoes. They're as essential as your aprons and goggles. So, what have we learned so far? When you see the following emergency, what should you do immediately? More than one answer may be correct. A, get the fire extinguisher and put out the fire thoroughly. B, dump water on the fire. C, get the fire blanket and smother the fire. Or D, run from the room, leaving the door open for easy access to call an emergency number. The correct answers are A and C. B is wrong because some fires are made worse by adding water to them, or at least are not controlled by water. D is wrong because you should never run in the lab. If there is a fire and you cannot reach an extinguisher or fire blanket, crawl away to avoid harmful gases and smoke. Close the door and call an emergency number. Doors should be kept closed to contain the fire. So after everyone is evacuated, the door should be closed. Question 2. While you are using a piece of electrical equipment, you notice it has a frayed wire. Put the following steps that you or someone should perform in the proper order. A, unplug the equipment. B, continue the experiment with a replacement piece of equipment. C, alert the teacher. D, turn off the circuit breaker or unplug the fuse to turn off the power. And E, turn the power on. The correct order is as follows. The first step is C, alert the teacher. Don't assume anything. Don't touch anything. The second step is D, turn off the circuit breaker or unplug the fuse to turn off the power. The teacher makes sure no electricity is flowing by disconnecting the circuit breaker or fuse so there's no risk of electrical shock. The third thing you would do is A, unplug the equipment. Now that the power's off, it's safe to do so. And the fourth thing you would do is E, turn the power on. Finally, step 5 would be B, continue the experiment with a replacement piece of equipment. Question 3. Which of these heating sources can cause an electrical hazard if not properly used? A, a candle. B, a Bunsen burner. C, a hot plate. The correct answer is C, the hot plate. Our symbol for electrical hazard is this. Question 4. What is the appropriate symbol or symbols for hazards posed by the Bunsen burner? More than one answer may be correct. The correct answers are A, D, and E. A, the Bunsen burner has an open flame, so it's a fire hazard. D, the Bunsen burner can flash when you light it. And E, you can burn your hands from the heat of the flame directly or from objects that you heat with the flame. Question 5. Which of the following pieces of safety gear is not essential for all lab sessions? A, eye protection or goggles. B, clothing protection or your lab apron. C, foot protection or closed shoes. Or D, rubber gloves. The correct answer is D, since not all experiments, especially ones using heat, which could melt rubber gloves, require them. Your teacher and common sense should tell you when you need hand protection. And there are different kinds of gloves for different situations, like heat-resistant gloves that don't melt. See you next time.
Look at these goggles. They look goofy.
I'm not going to wear these. I got contacts so I wouldn't have to wear glasses.
Look at this apron. It's awful. Everyone's always telling me what to do. I don't see why I have to wear this. I'll just wear some old clothes.
More stupid rules.
In this class, we don't do anything without a reason. That's because this is science. I'm glad you're questioning the rules, because in science, we don't take anything for granted. The lab is the place where we find things out, so we always have to be prepared for surprises. In fact, that's how scientists make discoveries. So ask questions and try to find answers. That's rule 1 in this class. Expect to be surprised. And because we can expect the unexpected, there are rules and procedures, so you'll need to follow directions. Most are to protect you, like these high-fashion lab aprons and eye protection. In this class, we're going to focus on lab safety awareness to help you avoid common accidents. Being safe in the lab means developing good habits, using your common sense, and staying alert. Remember, in the lab, surprises can and do happen. So no matter how lab safety aware you become, there's no prospect of anticipating every accident. So practice safe science. Wear your safety gear, follow lab procedures and directions, and listen to your teacher. Surprises will happen anyway, so don't assume anything. Let's try an experiment. I'll take this bottle labeled acid and make a dilute acid solution. Should I add water to acid or acid to water? Maybe you think it doesn't matter. Let's have someone come up here, please. Yes. Hi, remember me? I'm Mrs. Williamson.
Hi, I'm Laurel.
I'll put a little water into tube 1, which I'll mark W1, A2, because I'll put water in first and acid second. Tube 2, I'll mark A1, W2, because I'll add things the other way around. And into tube 2, I'll put about the same amount of acid as I had water in tube 1. Now, to tube 1, I'll add approximately the same volume of acid as I had water, and to tube 2, I'll add about the same amount of water as I had acid. Now, Laurel, if you'll place your fingers lightly on the 2 tubes, like this, you can tell the class what you observed.
That's crazy. One's hot and the other one isn't.
Right. So, the rule is, when you're diluting acids, always add acid to water. never water to acid. Can you guess what might have happened if I'd used an even stronger acid and diluted it by adding water to the acid?
It would get really hot, maybe even boil.
And it could spatter on your hands, clothes, or in your eyes. So just in case we make mistakes or something unexpected happens, we need to wear our eye protection and aprons when working with chemicals. And you may have noticed that I tend to hold tubes tipped away from me, just in case. And speaking of making no assumptions, what's in these other tubes, Laurel?
I don't know.
Being a thorough scientist, I have my secrets. I've labeled them. But what if I'd forgotten to label them, or if the marking came off? Chemicals have different properties, and if I knew what I'd started with, I might be able to figure out what was in each tube. How?
They might smell different from each other.
Good point. Since we're scientists, we don't sniff chemicals like Fido sniffing in the grass. We smell chemicals by wafting. So we aren't jolted by unpleasant or even harmful fumes. Tell the class what the chemicals smell like, Laurel.
Okay. This one's nail polish remover.
Close. And the next?
This one doesn't smell like anything.
Very good. And the third one?
This one smells sour.
Very good description. And next?
Ammonia. Ugh.
You got that one right. And?
This one's bleach.
Exactly. What else should we try?
How about tasting?
That might work well in the kitchen, but this is a lab. In the lab, we don't go around tasting and touching chemicals because they might be dangerous. If you don't know what something is, ask me what it is. In fact, never touch or taste chemicals unless you are specifically told to do so. Keep lids closed tightly when chemicals are not in use. And if chemicals should get on your skin or clothing, immediately rinse with water, then notify the teacher. Protect your hands appropriately, and if chemicals do get on them, rinse, wash, and rinse thoroughly. Now you can see why labeling things is so important. Make sure to label each container and keep track of what you add to each container. Why do you think we have a rule that we don't eat or drink in the lab?
We don't want to eat poison by mistake.
Bravo, Laurel. It's one thing to pick up a glass of tomato juice instead of orange juice. You might prefer one to the other, but both are safe. But some chemicals are very dangerous and can make you sick. Some are so dangerous that it takes only a little to kill you. So we need to be very careful and never eat or drink in the lab. Got it? Okay, let's get back to our problem of identifying liquids. Just because we know the name of a liquid or solution doesn't mean we know what it will do in every situation. Let's take these 3 handkerchiefs that I've stretched over frames, and I'm going to put a little bit of clear liquid number 1 onto handkerchief 1, and we'll put a little bit of clear liquid number 2 onto handkerchief 2, and a little bit of clear liquid number 3 onto handkerchief 3. Now, if I pick the handkerchiefs up so that both you and the class can see, what's going on here?
Handkerchief 1 and 2 look the same. But look at handkerchief 3. It's burning a hole through it.
Right you are. Now, I'll get an egg, crack it into this Petri dish, and place a little bit of that same clear liquid number 3 onto the egg, which has some materials in it that have some similarities to, say, your eye. Now, would you observe for us again, please?
The egg white is turning white, like it's being cooked.
Good observation. And you can't uncook an egg or an eyeball. Ladies and gentlemen, make no assumptions. As you can see, it can cost you dearly. What do you think of our ugly lab aprons and eye protection now, Laurel?
I'll be wearing mine.
If you spill anything in the lab, we need to get it up right away. So if you see a spill, call me. Why not let water or anything else just dry up? Greta? The slip can cause a fall, which can cause an injury in any environment, but it's especially dangerous in the lab because
You could cause another accident by bumping into someone else or by knocking over something.
and that can cause some of the other problems we've been talking about. Thanks, Laurel. You can go back to your seat now. And watch out for that wet spot on the floor. Now, if I can have another volunteer. Nick, how about you?
I never volunteer.
Well, consider it a request. Let's see how important it is not to make assumptions about new situations. I'll take 2 solids, and I'll put a little of the first one into this tube. And a little bit of the second one into the second tube. Next, and I'll put some water into each of the tubes. And next I'm going to put a thermometer into the tubes. And as soon as I do, I want you to read the thermometer and tell us what the temperature of the 2 solutions is. If you have trouble seeing the numbers, what would be another way to figure out the temperature?
Touch the tube like Laurel did last time?
Of course, using a thermometer is safer, and we can learn what the temperature is more accurately. But then again, thermometers have little temperature ranges, and if we go far outside them, a thermometer could break. I think it would be prudent for me to pick up the tubes one at a time and have you tell the class how they feel, just like that.
This one's hot.
Very good. And this one?
And this one's cold.
So, sometimes things get very hot, and sometimes things get very cold. Thank you, Nick. Don't go anywhere just yet. We'll be needing your services again in just a minute. In the case of the first tube, formation of a solution resulted in energy being given off, and the tube became hot. In the case of the second tube, energy was absorbed, and the tube became cold. So don't assume anything. Something may look like water, and it may not be water. Sometimes formation of a solution results in energy being given off, and sometimes it results in energy being absorbed. And if you have any doubts about the temperature of a vessel, handle it with tongs, special gloves, or insulated material such as a potholder. Keep glassware from touching your hands directly unless you know it's safe to touch. If you have any doubts, don't risk touching it. That's in fact why we use test tube racks, or if the racks don't fit our tubes, special setups so we don't have to touch the tubes directly. It also decreases the chance of extra spill. Don't worry, I haven't forgotten you, Nick.
I know. I'm unforgettable.
We've just seen that sometimes things get very hot or very cold in the lab, and not all glassware can take that. Glassware that can be safely cooled or heated is specially marked with a brand name like Pyrex, Kymax, or Tech. Under no circumstances should you heat or cool anything unless you're using temperature-resistant glassware. And you can tell if it is temperature-resistant by looking for the brand name. Can you see the brand name on the top of this tube, Nick?
Real clearly.
Then you know it would be safe to use for heating things, say with a candle or a Bunsen burner, or for running reactions in which energy might be given off or energy might be absorbed.
Sorry, am I an exciting guy or what?
It's really okay. In fact, it gives us an opportunity to learn how to clean up broken glass.
I always clean up my messes.
Whether in the kitchen or the lab, avoid picking up broken glass with your bare hands. Just sweep up as much of that as possible, and I'll get the little bit that's left with this damp paper towel. Then we'll discard the sweepings and the loaded towel into this container that's provided for that purpose. Thanks for the demonstration and the cleanup.
Thank you. Thank you.
You're welcome. We've all broken glassware or dishes, and scientists break things in labs. But there are dangers when we break things in the laboratory that don't face us in our homes or other places. There may be something poisonous or dangerous in the things we break. If you see that glassware is cracked, chipped, or broken, report it, and I'll exchange the broken glassware for a new piece. Then we'll place, not toss, the flawed glassware in the special broken glass container. We want everyone to know when using or emptying the container that it may contain broken glass, and that's why we have a special place for broken glass. See how sharp this little piece of broken glass can be? Why, it's as sharp as this scalpel. When you use tools, remember they're not toys. And when you use your dissecting tools, use your common sense. Use scalpels, razor blades, dissecting needles, and other sharp instruments with great care. Remember, they're designed to cut and pierce. So that means they can cut and pierce you. Just as good cooks in the kitchen and carpenters or others who use tools never cut towards you. You don't want to be performing an unintentional dissection on yourself. If you do cut yourself in the lab, let the teacher know right away. Come gather round and watch me dissect a part of a flower that may be familiar to some of you. We take the scalpel, cut away, and we can use dissecting tools to expose parts of the flower. Notice that I hold the dissecting needle gently but firmly. It's not a barbecue skewer. And by the way, these instruments are not sterile, so we don't want them to cut or pierce us. If you do feel a jab or you cut yourself, notify the teacher immediately. So cut away from yourself. And don't forget to wear your safety glasses when you're using sharp instruments. You never can tell if something that you're cutting might come flying towards your eyes. Okay, ladies and gentlemen, if you'll return to your places, it's time for the video quiz. Question 1A. A student carefully reads directions for the next experiment. The student is to heat a solution in a test tube. Correct the student in the picture by correcting the mistakes. There are 6 errors in the picture. Okay, number 1. The student has no goggles, so dangerous chemicals could splatter and hurt her eyes. Number 2. The student is drinking in the lab. and risks poisoning herself if the drink gets contaminated, not to mention the risk of distracting attention from the experiment at hand, which could cause other accidents. Number 3, the student isn't wearing an apron. So, if chemicals splash or boil, the student could damage her clothes, or, even worse, her skin. Number 4, her hair isn't pulled back, so it could catch on fire. Oof. Number 5, the test tube pointed toward the student means the chemicals that could come out of the test tube come out all over her. And 6, the test tube could shatter from the heat because it's not heat resistant. It's not marked Pyrex, Kymax, or Tech. Scary. Question number 1B. What is one thing the student is doing correctly? There are 3 possible correct answers. 1, the student is standing. It is excellent lab procedure to stand because you have more freedom of movement and more control over your work. And, in case something goes wrong, you're already on your feet. 2, the student is using safety matches, which gives her control over the flame as she lights it. And the 3rd correct answer is that the student is using a test tube holder to avoid getting burned by the test tube when it gets hot. Question 2. What safety symbol or symbols are associated with this activity? A, poison hazard, B, fire hazard, C, eye hazard, D, hand hazard, E, sharpness hazard. The correct answers are C, D, and E. C, because a flying piece of tubing could hit the student in the eye. D, if the student is cutting towards himself, it would be easy to cut a hand. And E is the most apparent answer, because a scalpel is a sharp object. Question 3. It's a rule not to eat or drink in the laboratory environment. Why? A, you could eat something harmful, sickening, or poisonous. B, you could eat something you didn't mean to by mistake. C, you could eat something contaminated by chemicals, germs, etc. D, all of the above. There are many reasons why no eating, no drinking is a good rule in the lab. All of the above is the correct answer. Now that we're at the end of this lab session, we need to clean up for the next one. Help me clean up the work areas. Return all the lab equipment and supplies to their proper places so the next class can find them too. Be sure all the burners, water, gas lines, and any electrical appliances are off before you leave the lab, unless I've specifically asked you to leave something on. Are we done yet? Yes, Roy.
Not until we wash our hands.
Excellent. Good safety awareness, Greta. I wouldn't even think about eating that mint in the lab. And I wouldn't touch my eyes if I were you either. Please don't take off your goggles and aprons until you've washed your hands. Then you're done. Wash your hands, please. Thank you. Nice work today.
Oh.
Walk, please. Don't run. Still in the lab. Thanks. Good work today.